Welcome to Get Your FRQ On. This question is from 2008. It's question 4, and it is not calculator active. In the question stem, we are provided with a particle moving along the x-axis, and a graph of the velocity of that particle is provided. We are also given a handful of bits of information about this particle. For example, we are given where the x-intercepts of the graph of the velocity is, where the graph of velocity has a horizontal tangent line. And we are also given the area of certain regions for that graph of the velocity, which we will use throughout this entire question. We will need all of that information. In part A, we are asked to find the time and position on the interval from 0 to 6 when the particle is furthest to the left, and to justify that conclusion. All right, we are given in the question stem that the position of the particle at t equals 0 is -2. We're also given from the question stem that the area of the region bounded between the graph of the velocity function and the x-axis between 0 and 3 is 8. We are given that the area of the region between the velocity graph and from 3 to 5 is 3, and from 5 to 6 is 2. Now, the way that this information is presented, it gives us that the area of the regions are 8, 3, and 2, but that doesn't mean that the value of those integrals are 8, 3, and 2 as well. All right, for example, if one of these regions is under the x-axis, then that integral would be negative, not positive. But the area of the region would still have a positive sign because it's an area. All right, so if we look at the graph for the velocity of this particle, right, we see that the velocity is negative for all values of t between 0 and 3 and between 5 and 6, and that it's positive only between 3 and 5. All right, so because of this, we may conclude that these integrals actually have the following values. The integral from 0 to 3 of v of t dt is -8, not +8. The integral from 3 to 5 of v of t is +3. And the integral from 5 to 6 of v of t dt is -2. So, using this information and the initial condition that the particle is at position -2 when t is equal to 0, we can conclude that x of 3 is -10, x of 5 is -7, and x of 6 is -9. All right, so when is the particle furthest to the left? When x is 3, right? And its position is -10. Now, why did we pick those values of x? Because the velocity function has zeros at 3, 5, and 6, we know that the particle has come to a stop at those points. All right, so those would be your extrema. You know, when is it furthest to the left, furthest to the right? So that's why we picked those points. All right, for part B, we are asked how many times between 0 and 6 seconds is this particle at position x equals -8, and to explain. All right, we are given in the question stem that this velocity function is differentiable, which is good because that implies that the velocity function is also continuous, which we will need in order to answer this question. All right, since the position of the particle at t equals 0 is x of 0 equals -2, and based on the graph of velocity, v of t is negative for all values of t between 0 and 3, we may conclude that the particle is moving to the left for that entire interval. All right, at t equals 3, x of t equals -10. But since it started at -2, we know that because -8 is between -2 and -10, there's some point, some value of t on the interval from 0 to 3 where x of t equals -8. All right, likewise, we know that x of 3 is -10, and the velocity is positive for all values of t between 3 and 5, so we can conclude that for those values of t, the particle is moving to the right for that entire interval. At t equals 5, x of 5 has position -7. right? Since negative 8 is between negative 10 and negative 7, we know that there's some other value of t between 3 and 5 where x of t equals negative 8 again. Since the position of the particle at t equals 6 is negative 9, and v of t is less than 0 for all t between 5 and 6, we conclude again that the particle is moving to the left for the entire interval between 5 and 6. Right? And since x of 6 is negative 9 and x of 5 was negative 7, negative 8 is between negative 9 and negative 7, so there's another value of t in the interval from 5 to 6 where x of t is negative 8 again. And that gives us a total of 3 times on the interval from 0 to 6 where x of t is negative 8. In part C, we are asked to consider the open interval from 2 to 3, and we are asked if the speed of the particle is increasing or decreasing on that interval and to provide justification. Since we're given the graph of v of t in the question stem, our justification should be based on that graph. It's one of the only things we know about this particle. Right? Based on the graph of v of t, we can conclude that the interval from 2 to 3, that v of t is in fact negative. Right? It's pretty obvious from looking at the graph. Right? But in order to determine if the speed is increasing or decreasing, we also need to know the acceleration of the particle on that same interval. Well, the acceleration of the particle is the rate of change of the velocity. Right? And since we have a graph for v of t, we can use the graph to make inferences about the acceleration or the rate of change of v of t using the graph. Right? Looking at the graph of v of t on the interval from 2 to 3, we can see that v prime of t is positive. V of t is increasing on the interval from 2 to 3. It's clearly visible from the graph. All right, so since v of t is negative on the interval from 2 to 3, but v prime of t is positive on the interval from 2 to 3, the speed of the particle is decreasing on that interval. In part D, we are asked during what time intervals is the acceleration negative, and to provide justification. Since the acceleration of t, or a of t, is the derivative of our velocity function, v prime of t, whenever a of t is less than 0 is going to correspond to intervals where our velocity function is decreasing. Based on the information given in the question stem, where v of t has a horizontal tangent line, we know that v of t has a minimum value at x equals 1 and a maximum value at x equals 4. Right? We therefore conclude that v of t is decreasing from 0 to 1, increasing from 1 to 4, and decreasing again from 4 to 6. Right? We can conclude from that the acceleration is going to be negative, i.e. the slope of the graph of v of t, on the interval from 0 to 1, and again on the interval from 4 to 6.